So hi guys, my name is Don Mabatid. For today's exercise is obtaining a ship position by estimated position method. So the scenario is at 1330 vessel at the vicinity of the west part of Pana Island on course of 200 degrees true course times 10 knots with a falling tide with tidal stream speed is 0.6 knot. The OW observed Port Lighthouse. It bears 330 degrees relative bearing with a distance of 6 nautical miles. Plot the ship estimated position. So at Lighthouse, it bears 330 degrees. So we cannot use the 330 degrees relative bearing. So what we need to do is relative bearing plus true bearing. So it says here that we got 330 degrees relative bearing and 200 degrees true bearing. So 330 degrees relative bearing plus 200 degrees true bearing is equals to 530 degrees true bearing. So 530 is exceeding to 360 degrees true bearing. So what we need to do is 530 bearing and 360 degrees true bearing. We need to subtract it. So we got 170 degrees true bearing. So we already got the true bearing of the Pusher Lighthouse, which is 170 degrees true bearing. So right now we will trace the 170. 170. So what we're gonna need to do is from 170 degrees we need to drag the triangle ruler to Port Lighthouse, which is this one. So Port Lighthouse 170 Port Lighthouse, then trace. So now we get the line of position, which is this. So we will get the range of the Pusho Lighthouse. So it is 170 degrees from Pusho Lighthouse, and the distance is 6 nautical miles. So 6 nautical miles. So it's 11 in here. So 11. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 6. 1, 1, 2, 3. 1, 2, 3, 4, 5, 6. So from Pusholat House. So make an arc. So now we will get the ship's bearing, which is about 200 degrees true. So first we'll find the 200 degrees. So 200 degrees. This one. So all we're gonna need to do is from 200 degrees, just need to drag the triangle ruler from here, there. Then make a line of position. So now we got already the fixed position of the ship. Then right here, 200 degrees through by 10 knots. So now, since we already got the fixed position, we will name it. We put this. It is fixed position at 13 1300s 30 hours. So it says here, calculate the distance run after an hour from the first observation. So since we got 10 knots, so half of 10 knots is 5 knots. Why? Because it says here after an hour. So 5 knots. So 1, 2, 3, 4, 1, 2, 3, 4, 5. 5. Then from here, then an arc. So this is after an hour in the first observation. So we'll name it is dead reckoning DR at 400 hours. So it says here we're asking with a falling tide with a tidal stream speed. So this is the symbol of the tidal stream speed. So the falling tide has 0.6 knot. So since this is our tidal stream, all we need to do is align this, then drag it where your 1400 is located. Then put a line, draw an arrow. So whereas is since this is 0.6 knots, then whereas half of it, so half of 0.6 knots is 0.3 knots. So 0.3 knots. So this is the one. So this interval here means 0.2. So 0.2. So in between in 1 and 2. So 1 and 2. So from 1400s here, then put an so this is where the falling, I mean the tidal stream speed is.